here, that's the drive line, and that's the driven line of two gears. You know, the actual teeth of the gears would be something like this, where that is solid material. And the same with this one here, you know, that be that type of thing where that is solid material. This one here, drive gear, it's pretty obvious. It's the one with the power behind it, the one that's forced to move, one that has a motor behind it. Say it goes that way. Now you just think it goes around that way. So here it goes like that. So this one goes like that. Now that's not important for the question I have in mind. So this one goes around clockwise, that one goes around anti-clockwise. But let's say that's not important. What I want to know is how many times that will turn if this turns just once. So we need to know how many of that circumference will fit into that circumference. So let's label these, shall we? That's drive A, that's gear A, and that's gear B. Now we know that the circumference, so is equal to pi times the diameter. Diameter, I've given you radius, so we have to double them, right? So we want the circumference of A. I'll put circumference, and if you like, let's introduce you to a notation. Circumference, C of A, right? Circumference of A equals pi times the diameter. So you can also write diameter times pi, it doesn't matter, it has the same effect. So the diameter is twice the radius, so that's 16 times pi. That's the circumference of A. Now let's have a look at the circumference of B. Equals, again, pi times the diameter, which is the same as diameter times pi. Now, the diameter is twice the radius. Radius is 5. So the diameter is 2 times 5, which is 10 times pi. What we need to know is how many of these will fit into that. How many of these will fit into that. So what we do is we go 16 pi divided by 10 pi. How many of these will fit into that? Well, we can write that as 16 pi over 10 pi, which again can be split like this. 16 over 10 times pi over pi. That, my friends, is the equivalent of 1. So it disappears. That's what they mean when they say it cancels out. So we just end up with 16 over 10. Now if we divide 16 over 10, we get 1.6. Now we're talking about revolutions, so don't forget your unit of measurement is revolutions. So 1.6 revolutions of that one equal a revolution of 1 of that one. Fairly straightforward when you know how to approach it. How many of these will fit in that? Straightforward answer, straightforward question. That's dealt with circumference of a circle. Now let's look at an example for area. Now you'll have to bear with me. I'll do the best I can on my sketch. Imagine we've got a column which is transmitting a load. There's something up here that's heavy and it's got a load coming down here, and it is sitting on a round disc of concrete, which in turn is sitting on soil. So the load that comes down the beam is then transferred to this concrete, which in turn is transferred to the soil underneath. Now suppose what we have coming down here is 600 kilonewtons, and believe me, for a building it'll be a lot more than that, right? And the radius of your concrete pad is 3 meters. Now if that load there was transmitted or transferred equally or distributed equally over the area of this concrete disc, what would it be? What would be its load in kilonewtons per square meter? So we need to know what the surface area of that circle is. Now we know that the area is equal to pi r squared. The more you write it, the more you remember it. Well, we know that in this case r is equal to 3 meters. So what we end up with is the area is equal to pi times 3 squared, which in turn is equal to pi times 9, but we normally write it the other way around. That is the area, surface area of that concrete foundation, is a proper word, I suppose, right? So that is its area in square meters. Don't forget your units of measurement. We got a load of 600 kilonewtons coming down totally. So for each square meter we have 600 kilonewtons divided by 9 pi square meters. But we want to know how much it is for 1 square meter. So we need to change 9 pi into 1. Well, that's quite straightforward in that we have, just looking at the numbers, ignoring the units of measurement for the moment, 9 pi, want to change that into 1, so we divide it by itself. Now if we divide the bottom by 9 pi, we also have to divide the top by 9 pi. That would then give us here, that will give us our 1, and it's in meters squared. Divide 9 pi into that. Well, let's have a look, shall we? Here we go. 600. Wait a minute, let's put that over here, shall we? 600. Divide that by, now we got a times there, so I'm going to put it in a bracket. 9 times pi. Now pi here is that brown. So I'll come up here, there's the brown, press that, and I get the pi, close bracket, don't forget. So now it is dividing it by that lot there, and we get this answer here. Now I'm going to round it off. 21, right, so it's 212206, 21.2206, I think. Let me make sure. 21220659. Well, the digits go on, you know. Okay, I want to round it off. Rounding. What's the rule of rounding? Here's a number 2, 1. Point, and put a gap between 2, 2, 0, 6, dot, 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 meaning they go on. Change the colour. Where shall I cut it off? Let's cut it off here, shall we? Let's cut it off here. That's your cut-off point. This number immediately to the right is less than 5, so we don't round that up. So it becomes 21.2 to 1 decimal place. I can't stress that enough. It's telling everyone you've rounded it. It's not an exact value. Now we bring in our units of measurement here, kilonewtons per square meter. So it is in fact 21.2 kilonewtons per square metre. And that is the load that is transmitted to the soil under that disc. Fairly straightforward once you're used to them.